Good afternoon, students and parents in Mr. Caspillan's class. I'm Mr. Caspillan, and I'm going to be going over the Reteach to Build Understanding and the additional practice for Lesson 4-2. Our first prompt says, one way to estimate a product is to round each number to the greatest place value that has a non-zero digit. It asks us to estimate 3 68/100ths times 19. If we are going to round each number to the greatest place value that has a non-zero unit in 3 68/100ths, my greatest number with a non-zero digit is the 3 in the ones place. In 19, that'll be the 1 in the tens place. When I look one digit to my right, I see a 6, and that is 5 or greater. So I know I'm going to round up to 4. When I look at one digit to the right of the 1, 9 is 5 or greater, so I will round my 1 up to 2, and all other numbers become a 0. 4 times 20, we can rewrite out to the side if we need. Any number times 0 is 0, as the 0 property states, and then 20, or the 2 times the 4, is an 8, making our product about 80. So when we are going back to this statement, so 3 68/100ths times blank is about blank, what we'll do is, since we see that they just dropped it down, we're going to drop down this 19 as well. And the estimated product that we have is a 80, so I'm going to write 80. The second way that we can estimate products is through compatible numbers. Compatible numbers are numbers that are close in value to the actual numbers and are easy to add, subtract, multiply, or divide mentally. 24 8/10ths times 4 21/100ths. We can round both of these numbers to 25 and 4. We see that we round to the nearest 1 for both numbers, giving us 25 times 4. 25 times 4, we can write it out to the side if we need to. 5 times 4 is 20. So we record 0 and raise the 2 tens. And then 2 times 4, or 20 times 4, is 80. Plus another 2 tens is 100. So we record the 0, raise our 1, and drop our 1. So 25 times 4 is 100. So 24 8/10ths times 4 21/100ths, my apologies, is about 100. For number 3, it asks us to estimate 158 times 32/100ths by rounding. We can round 158 to our hundreds place if we like. One digit to the right is a 5. 5 is 5 or greater, so we are going to round up. Our 1 in our hundreds place becomes a 2, and the other numbers become zeros. As for our 32/100ths, our greatest non-zero number is the 3 in the 10th place. If we look one digit to the right, 2 is less than 5, so we are going to round down. So we will have 0 and 3/10ths. The reason why we have it as 3/10ths instead of 30/100ths is because the zeros at the end do not change the value of the number in a decimal. If we don't need it, we can get rid of it, so we can have 3/10ths. So we should fill this out with the numbers that we rounded. We have 200 times 3/10ths. We can practice the RAM method now. To rewrite this equation, we need to change our 3/10ths to make it a whole number. We will move our decimal point one space to the right. making our new equation 200 times 3. Let's do 200 times 3 on our whiteboard. Or if you don't have a whiteboard, you may continue to do it on your paper. 200 times 3. We're going to multiply our entire unit times our multiplier. For these first two numbers, we can apply the 0 property, where any number times 0 is 0. So 0 times 3 is 0, and 0 times 3 is, once again, 0. Now we have 200s times 3. If we take our knowledge about multiplication and do 2 times 3, we should get 600. So in A, we have 200 times 3 equals 600. But we're not done. We need to do M. We moved our decimal point at the beginning 1 space to the right. So with our product, we need to move our decimal place 1 space to the left. Our new decimal point should be between the two zeros, making our estimated product 60 and 0/10. But because we do not need any zeros after the decimal point, we can get rid of it. So your estimated product for 200 times 3/10 is 60. Number 4. Estimate 158 times 32 hundredths using compatible numbers. The compatible numbers that we have are 150. A compatible number that we have for 32 hundredths would also be 3/10. If we do 150 times 3/10, we can again apply our RAM method. I'll write it out on the whiteboard so that it's bigger. I apologize for not doing it on the first one. So we have 150 times 0 and 3/10. We need to move our decimal point 1 space to the right in order to make our new equation 150 times 3. If we apply the standard algorithm, we will have 150 times 3. We apply our 0 property here because 0 times 3 is 0. 50 times 3 is 150, so we were going to record the 5 in the tens place and regroup our 100. Then we have 100 times 3, which is 300, plus our regrouped 1, making our product 450. We are not done because again, we have to move our decimal point back 1 space to the left. We always place our decimal after the ones place, which is in this case our 0. We move it 1 space to the left, making our estimated product 45. Number 5 asks, is each estimate an overestimate or an underestimate? When we simply round in, we had 200 times 3/10. Our actual product, since we rounded up a lot from 158 to 200, should be an overestimate. For our compatible numbers, we rounded 158 down to 150. So we should know that our answer is an underestimate. Number 6 asks us, which estimate is closer to the actual product. We have to ask ourselves, is 158 closer to 150 or 200? Well, 150 is only 8 digits away from 158, while 200 is 42 digits away from 158. So, we can round using the greatest non-zero digit in each number. My greatest non-zero digit in 53 hundredths is the 5 in the tens place, and my greatest non-zero digit in 29 is the 2. When I look at one digit to the right of the tens place, 3 is less than 5, so I would rewrite this as 5/10. When I look one digit to the right of 29, when I look one digit to the right of the 2 in 29, that is the 9. 9 is 5 or greater, so I would round my 2 up to a 3, and all the following numbers would become 0. So my new equation is 0 and 5/10 times 30. Now we can apply the RAM method. So when we rewrite, we have 0 and 5/10 times 30. We need to move our decimal point to make our 5/10 a whole number. We're going to move one space to the right. That should make it 5 times 30. When we apply the standard algorithm, we are used to seeing the bigger number on top, so that's what we will write this as. We apply the 0 property because 0 times 5, any number times 0 is 0. And then 30 times 50, or the 3 times 5 is 15. We will record our 5, raise our 100, and since there are no other hundreds to multiply by, we will just drop it. We are not done though, because we now need to do the part where we move our decimal back. So in 150, our invisible decimal point is at the end of the number. We move it one space back. Our new decimal would be placed between the 5 and the 0. So our estimated product is 15. So 0 and 5/10 times 30 equals 15. I'll give you a second to take a look at the entire paper. Make sure that you've copied out anything that you need to. Okay. Times 2 is 40, because 0 times 2 is 0 and 2 times 2 is 4. Now, in number 2, we are asked to use compatible numbers to estimate 12 times 0 and 49 hundredths. If we're doing compatible numbers, I would say that we can leave our 12 alone. But we can look at the 10th place in 49 hundredths. Look one digit to the right. 9 is 5 or greater, so we should now have 0 and 5/10. Since we have a number that is less than 1, we are going to apply the RAM method. So we have 12 times 0. We start off with 12 times 0 and 5/10. We need to move our decimal point 1 space to the right in order to make our decimal number a whole number. So now we have 12 times 5. Now we need to apply the standard algorithm. We have 12 times 5. For our ones place, we have 2 times 5, which is 10. We will record the 0. Carry our 1. 1 times 5 is 5, plus our regrouped 1, which is 6. Our last step is to move the decimal back. We have an invisible decimal right after our 0 in our ones place. We moved 1 space to the right earlier, so now we have to move 1 space back to the left. So our new product is 6 0/10. But as I said, any number after a decimal point, if it's a 0, doesn't matter. So we can get rid of it. So 12 times 49/100 is about 6. In 19 3/10 times 6, we need to apply the RAM method. So what I'm going to try to do is start from a couple of them where I write everything out, and as we continue to progress, I'll try to shorten up these steps. We have 19 3/10 times 6. We know that we need to move our decimal point 1 space to the right. So now we have 193 times 6. What we need to do is estimate. What can we estimate to? I feel like we can leave this 6 alone, but we can round to our nearest hundreds place. 1 digit to the 1 is the 9, so we should have it as 200 times 6. To apply the standard algorithm, we have 200 times 6. We apply the 0 property twice because we have 2 zeros. And then 2 times 6 is 12. Again, we're not done because now we need to move our decimal point back. We place our invisible decimal point after the 0 in the ones place. We move 1 digit back to the left. And now we should have 120. This, if you're able to fit it on your paper for number 3, you would have it equal to 120 with all of this information packed into this space. Now we have 345 times 5 79/100. What I'm going to do first is estimate on paper so that I remember. So this should be 20 times 6. And what we can do here is round to the nearest hundredths. Make it to where we're giving ourselves the easiest one to compute because it's not specific. It doesn't tell us to round to a specific place value. So I can round this down to 300 because one digit to the right is a 4. And then I can round up to 6 because one digit to the right of my ones place is a 7, which is greater than 5, or 5 or greater. So now we don't need to do RAM. There's no decimal anymore. So I guess we can just look at A, where we have 300 times 6. We apply the 0 property twice, where we have 2 zeros, because any number times 0 is 0. 3 times 6 is 18. So our estimate will be about, sorry, and I should have done this earlier. An estimation sign looks like 2 squiggles on top of each other, similar to an equal sign. 180. For number 5, we have 10 and 66 hundredths times 46 hundredths. I'm again going to round to my greatest non-zero digit. This 9 can be rounded up to 10 times, and then we have 4. One digit to the right is 6, so we can round up to 0 and 5/10. So I'm gonna try to move a little quicker now. 0 and 5/10. I need to move it one space to the right so that I can make it a whole number. So I can rewrite this as 10 times 5. 10 times 5, we apply the 0 property once. 1 times 5 is 5, so we have 50. Mentally, I knew earlier that I moved my decimal point one space to the right. So now I need to move my invisible decimal point one space to the left. If I do that, I would have 5 and 0/10, but I don't need that 0 or that decimal. So my estimated product is about 5. For 8 and 2 hundredths times 70, I think I can leave my 70 alone, but I will change my 8 and 2 hundredths to make it to where I shouldn't have a decimal by rounding to the nearest whole number. I will look one digit to the right. 0 is less than 5, so I round down to 8 times 70. Here, all I have to do is apply the standard algorithm because there are no decimals to move anymore. I'll write the bigger number on top just because it's what we're used to, and apply the 0 property. 7 times 8 is 56. So my estimated product is about 560. Number 7. 1 and 56 hundredths times 48. What I can do is again round to my greatest non-zero digit. 5 is 5 or greater, so I'm going to round this up to 2. 8 is 5 or greater, so I'll round my 4 up to a 5 and turn the rest of the number into a 0. 2 times 50 can be rewritten as 50 times 2. Any number times 0 is 0. 5 times 2 is 10. So my overall estimated product is 100. What I'll do is I'll pause here and you can attempt to solve 8 through 14, which I will check tomorrow. Let's move on to the back side of this paper. Remember, the back side of my practice sheets are always more like the assessment than the front side. We need to know how to pull information from tables and paragraphs or sentences in order to do the right thing. Number 15 says, can Miss Davis and her 2 sisters get their hair colored for less than $100 if they include a $10 tip? Explain. So, what we can do, we need to know how much money it costs to get hair colored. From the table, it says that coloring costs $28.95. What I can do, I'll log that, $28.95. Then, the other piece of information that I need to pull is that the people getting their hair colored are Miss Davis and her 2 sisters. Miss Davis is one person, and she has 2 sisters, for a total of 3 people. Now I need to estimate. I don't want to make it hard on myself. So, what I'll do is I will estimate to the greatest non-zero digit number, which is my 2 in the 10th place. 1 digit to the right is an 8, so I can round up. Now I have $30 times 3. But I have one more piece of information that I have. I need to include a $10 tip. So, I need to add plus $10. This may be confusing though, so what I'll do is I'll section it off with the parentheses so I know to do it first. Now we have 30 times 3. 30 times 3 is, we apply the 0 property once, and 3 times 3 is 9. We have $90 plus the $10 tip, which is $100. So, we made it easy on ourselves by rounding, but this is not our final answer. We need to know if they can afford it for less than $100. Our estimate is exactly $100. So, here's my train of thought. The original cost is $28.95. I rounded up to $30. So, $100 is an overestimate. Overestimates are more than the actual product. So, I should know that Miss Davis and her 2 sisters can get their hair colored for less than $100 if they include a $10 tip. Haircuts, how much will they pay in all? So, it says also. That means that I need to add however much it costs for the 3 of them to get haircuts to my initial product of 100. I don't need to find an actual product because it says about how much. My equation should look like $100 plus, and I'm gonna put these numbers in parentheses, It costs $14.95 to get a haircut. So it costs $14.95 to get a haircut, and there are 3 people once again. If I'm going to estimate, the best that I can probably estimate is by rounding to the nearest whole dollar. So I should have 100 plus 15 times 3. So 15 times 3, 5 times 3 is 15. 1 times 3 is 3, plus 1 is 4. So, again, $100 plus 5 times 3, which we know now is $45, is $145. Able to get from this was that there are 3 children with new raincoats. If each raincoat costs $25.99, they want us to find out what is $25.99 times 3 children, or so you might think. It says about how much, so we need to estimate. Let's turn our $25.99 times 3 to something that we can estimate with. If we want, we can estimate to the greatest non-zero digit, which is our tens place. We have a 2 in our tens place. 1 digit to the right is a 5, so we can round up to 3. All the numbers would become zeros, but since we know that we don't need the zeros after the decimal point, we have $30 times 3. So we have 30 times 3. We apply the 0 property, and then 3 times 3 is 9. Our product is $90. And then it says, is your estimate an overestimate or underestimate? So I know it is an overestimate. I'm going to shorthand this because I rounded $25.99 to $30. $30 is more than $25.99, so I know that the actual product is less. For number 18, some Native American tribes made jewelry with dentalia shells. Each dentalia shell is about 1 5/10 inches long. About how much longer would a necklace made with 24 shells be than a necklace made with 18 shells? Use compatible numbers. So, we have a lot of information here. It gives us that each shell is a 1 5/10 inches long. We have an equation where they want us to find how long it would be with 24 shells and how long it would be with 18 shells. So we have 1 5/10 inches times 24 and 1 5/10 inches times 18. Now what we need to do is find these compatible numbers. I think that we can estimate 1 5/10 to 2. For 24, I think that a close enough number is 25 because 24 is closer to 25 than it is 20. For 18, I think that 18 is closer to 20 than it is to 15. So, if we apply the standard algorithm to both of those problems, we have 25 times 2, which is 50. I apologize. And then 20 times 2 is 40. I need to remember that these represent an amount of inches. That last part of the problem is how much longer would a necklace be made with 24 shells than a necklace made with 18 shells? They want us to subtract. So, 50 minus 40 is 10 inches. So I know that a necklace made with 24 shells is about 10 inches longer than a necklace made with 18 shells. For number 19. A youth hockey league is selling boxes of popcorn to raise money for new uniforms. Sydney sold 9 boxes for a total of 72 in sales. Use the bar diagram to write an equation to find the value of C, the cost of each box Sydney sold. For the first time ever, we see that we have our total, but we don't know how long everything else is. Algebra, when we go into middle school and high school, will be a little bit different to what we are learning now. So we know our total, which is $72. We know that there are 9 boxes. We need to find out what is in this blank. What's here? What we have to do is some algebra. It's all right if you don't understand. This problem is just for exposure. In order to find this blank, which is C, our variable C, we have to somehow find a way to get our variable C by itself. So there should be no other numbers. In order to do that, we would divide 9 by 9 and 72 by 9. If we know how to multiply a number by 9 to get to 72, we should be able to find a number that is divisible by 9 from 72. That number is 8. So it costs $8. For this assessment practice, what I'll do is I'll just read it. You'll come in tomorrow having attempted it already. So, rounding to the nearest tenth, which of the following give an overestimate? Rounding to the nearest whole number, which of the following give an underestimate? You can try these problems on your own. I'll see you all tomorrow. Check in your work. Have a great rest of your night.